Hello students, in this video we are going to solve this question of JEE Advanced, which has been asked in JEE Advanced examination, I think 2018, and it is related to the topic of Newton's law of cooling. Okay, so we are going to solve this question. In this question it has been given that a container with 1 kg of water, the mass is given as 1 kg, kept in sunlight, which causes the water to get warmer. It is receiving the sunlight which causes it to warm. The average energy per unit time per unit area, the average energy per unit time per unit area is received as 700 watt per meter square, and it is absorbed by the water over an effective area. So the effective area is taken as 0.05. Over this area this heat has been absorbed. So Q by T will be A into 700. So 0.05 into 700. This is the rate of heat gain which is given to water due to sunlight. So assuming that the heat loss from the water to the surrounding is governed by Newton's law of cooling. So here we can apply Newton's law of cooling. According to that, rate of fall of temperature with respect to time is T minus T naught. Here T is the body temperature or water temperature and T naught is the surrounding temperature. The difference in degrees Celsius, we have to calculate the temperature of water in the surrounding. This entity we have to calculate after a long time. Why it is given after a long time? What happens after a long time? After a long time, steady state will be achieved. What happens in steady state? Rate of heat gain will be equal to rate of heat loss. Rate of heat gain will be equal to rate of heat loss by the water. So rate of heat loss will be equal to rate of heat gain. This is rate of heat gain, 0.05 into 700. So this is rate of heat gain, and rate of heat loss we have got due to steady state. Now if we take the Newton's law of cooling and remove the proportionality sign, we'll get K T minus T naught, and in place of dt we can write, we know dq is equal to ms capital dt. So in place of dt we can write dq by ms. So we are using dq by ms in place of capital dt, and dt is this K T minus T naught. So we get dq by dt is equal to K ms T minus T naught. So dq by dt is your rate of heat loss, which is 0.05 into 700. Now K ms we have to calculate, T minus T naught. Mass of water is given as 1. Its constant is given as 0.001. Constant is given as 0.001, and specific heat is given as 4200. Specific heat is given as 4200. Here we have to put everything. This multiplication will give us 35. K value is 0.01. Mass value is 1. Specific heat is 4200. T minus T naught. So it will comes out to be 35 divided by, I think, 4.2. T minus T naught. This 35 divided by 4.2 will give us 8.33. Okay, so this is the temperature difference between water and surrounding we'll get. So in the next video we are going to solve more questions of JEE Advanced. That's it from this video.